Let's continue from where we ended. Right? How much was what is your future value of the 10,000 that you have invested?
1,500. 1,500. 1,500.
Woman. Mr. Ezekiel.
Is 20,114. I round it up.
20,000.
Is 114.
That is for 5 years, and
yes.
Let me see if I'm getting. And we are investing 10,000, and
yes.
At what percent?
15%.
At 15%, which is 20,114, and
yes.
Yes. So that's how we do our future value. That is compounded. Take note, if something is compounded, and it means the amount that you get, that is the interest, you are adding it to the what? To the principal amount at the end of the year. That amount that you have got, you compound it and you reinvest the compounded amount in the following year, not as in simple interest. Are you together? Right? So that's the formula for future value on simple interest. Then we have future value, ordinary annuity. Future value on ordinary annuity, that is the amount that you'll be getting annually, the future value of ordinary annuities. We are saying the mathematical formula used for calculating future value of an ordinary annuity using compound interest is as follows. Future value of an annuity is equal to I, that is annuity amount or payment, that is the present value amount, multiplied by, let me increase, I multiplied by 1 plus I, the small I for the interest. Take note that this I is for the what? Present value amount. Are you together? Present value amount in quotes, multiplied by opening bracket 1 plus interest amount to the power n minus 1 over I. Are you together? Future value annuity, I multiplied by open bracket 1 plus I to the power n minus 1 over I, where the big I is the annuity amount of payment, then the small I is the interest rate, then n is the number of years or periods. Then we are told future value of an ordinary annuity person. A person would like to invest $5,000 at the end of each year at an annual compound interest rate of 14%. We are required to determine the value of the investment after 4 years. We are required to determine the value of the investment after 4 years by using the mathematical. We can't use, I know, do you have financial calculators so that we use our calculators? Hello?
Yes.
Yes, we do.
Financial calculator, not a simple calculator. All right, so I want you guys to calculate this future value or ordinary annuity, where you are told a person would like to invest 5,000 at the end of each year at an annual compound interest rate at 14% using this formula. So FV annuity future value is going to be I. If you copy this formula,
Yes, sir.
copy this formula. Future value annuity, which is equal to big I multiplied by open bracket 1 plus small I to the power n minus 1 over interest. Right together. Then we are told a person would like to invest 5,000 at the end of what? of each year at an annual compound interest rate of 14%. You are required to determine the value of the investment after 4 years. That is the future value of an ordinary annuity. So, Greek I, it's what? 5,000 multiplied by 1 plus I to the power n minus 1 over I. Let's calculate what we get.
99.
Right, are we done?
Yes.
What's the answer? What's the answer? Tracy Banda, what's the answer?
Sir, I'm still calculating, sir.
Okay. You're not calculating, Tracy. All right. Omuhle, what's the answer? What's the problem with your mic, Omuhle? It's over on mute. All right. Let's continue. We are saying the calculation will be as follows. I wish I had brought my iPad. I could have done the calculations on the iPad other than just you guys count. We are saying the future value is going to be I. The future value annuity, it's I multiplied by 1 plus I to the power n minus 1 over I, where we are saying we're investing how much? 5,000 at the end of each year. Then multiplied by 1 plus at what percent? 14% compound interest minus what? 1. So what you need to do first is calculate 1.14 to the power 4. Are you together? You just say 1 point, let me increase the size. You first calculate 1.14 to the power 4 and minus 1. So which is 1.6890 minus 1 over 0.14. This 0.14 is our interest element, which is 14%. 14% is good as saying 0.14. So you say 5,000 multiplied by 0.689 over 0.14. So 5,000 multiplied by 4.92, you get 24,606 if it's rounded off to the nearest whole number. Are you together? I hope we got 24,606.
Yes.
All right, so that's future value ordinary what? Annuity. That's future value ordinary annuity. Then under future value, we have the following last section: future value, annuity due, future value, annuity due. Take note, these formulas will not be provided. Hello?
Yes, sir.
Formulas will not be provided. Take note that they won't be provided. So you need to know them by head, right? A future value annuity due, the formula is I, that is for what? Annuity amount, I together, multiplied
Yes.
by 1 plus interest. Then earlier on, take note that these formulas, they are more or less the same, but they differ somewhere. For annuity amount, future value annuity, we're saying 1 plus I to the power n, right together. But now,
Yes.
on annuity due, we are saying 1 plus I, n plus 1, then to the power n plus 1, minus 1 over I minus 1. Take note that on future value annuity, we don't have this plus 1 and also minus 1. So for future value annuity, it's I multiplied by 1 plus I to the power n minus 1 over I. And then on future value annuity due, I multiplied by 1 plus I, n plus 1 minus 1 over I minus 1. Right together. So this is do you see the difference of our formulas? For future value
Yes.
annuity and for future value annuity what? Due.
True.
Right together. Then we are having this question. And we are saying, this I is the future value, is the present value amount, right together. The principal amount, which is the what? The annuity amount that you are going to pay, right? I is the PV amount for that current what? Year end. So our I is going to be our annuity amount. Then our small I is going to be the what? The interest. Then n is number of years or number of what? Of periods. Then we are told you intend to establish a savings account for your child's university education. When he enters high school, you make payments of $5,000 each into his account at the beginning of each year, and you earn compound interest of 8% per annum. On your investment, you are required to calculate the future value of the annuity due after 5 years, when your child would have finished his high school education. So using this formula, let's calculate the amount of our annuity due. Let's calculate the annuity due using this formula. Bongani, you tell us the answer. Bongani is to tell us the answer.
The question just disappeared.
Oh, you want the question? What's the answer, Bongan?
17,530.56.
17,000?
530.56.
Somewhere that way you missed it. There's somewhere where you missed it. Yeah. We are saying for future value annuity 2, we are saying 5,000 multiplied by 1 plus I, which is our interest element is 8%, which is 0.08. Right together. 1 plus I, close in brackets, N plus what? 1 minus 1. Take note that this minus 1 is subtracting the value for saying for 1 plus 0.8 to the power 6 minus 1. Whatever you get, you say minus 1. Right together. Then we say 5,000. You need to calculate this step by step. Right together. Don't just put everything at once. You might put everything like this, then calculate section by section. So I advise you, you calculate this first section first, of saying 5 plus 1, right together. Then you say 1 plus 0.0808, which is 1.08 to the power 6, which is 1.5869 minus 1 over 0.08. Then you say 1.5869 minus 1, you get your what? 0.5869 divided by 0.08. You divide this by 0.08, you get 7.3359 minus 1. You get your 6.3359 multiplied by what? 5,000. Right here. So the answer is going to be 31,679.65. Now rounded to the nearest whole number is going to be 31,680. So please be careful. You need to calculate these items section by section. If you put them on the calculator, they'll give you a what? Wrong answer. Right? We are done with our future value. Then we want now to calculate present value. Right? We had said the formula for future value is PV. Future value is equal to PV 1 plus I, closing brackets, to the power n. Right together. Right? I want you guys to make PV the subject of the formula. Make PV the subject of the formula. Let's make PV the subject of the formula.
FV over 1 plus A to the power n.
The value. divided by
What's the answer?
FV over 1 plus R to the power n. 1 plus I.
So we are saying for us to make PV the subject of the formula, we divide everything, right? We divide this side by what? 1 plus I to the power n, and so therefore our PV will be equal to FV over
1 plus I
to the power
to the power
n, right, together to the power n. So that's the formula of PV, right, together. That's the formula. You might just know the formula for FV. When you want now to calculate for PV, the subject of the what? Of the formula, right, together. You make PV the subject of the formula. Right, you are having this instance. So that's our formula. PV is equal to FV over 1 plus what? I. Right, together. Right, so the formula we have in this question, in 5 years from now, you want to buy a car valued 180,000. What is the amount that you must invest today at 10% compound interest per annum in order to reach your goal of 180,000 at the end of 5-year period? Let's calculate that using the formula. Are we done? Right, are we done?
yes.
Right, so our future value is 180,000, right, together, divided by 1 plus our interest element is what? 10%, right? To the power of how many years? 5. So which is 180,000 over 1.6105, which will get 111,767. That's the amount that we need to invest today for us to get 100 and what? and 80,000. So that's how we calculate our the present value. Right together. That's how we calculate the present value. Then present value ordinary annuity. Present value ordinary annuity. If you still remember on future value ordinary annuity, it was 1 multiplied by 1 plus I to the power n and minus 1 over I. Hello class. It was I multiplied by 1 plus I to the power n minus 1 over
To the
I.
power n.
To the power n minus 1. Right together at the end. Then over I. Then PV annuity.
Yeah.
FV annuity 2. It was I multiplied by 1 plus I, closing bracket, to the power n plus 1. And we subtract everything by what? Minus 1 over I. Then everything again what? Plus what? It's n plus 1 there. N plus 1 minus 1 and again minus 1 down there. So the formula for PV annuity, it's I multiplied by 1 minus 1 over 1 plus I
1
to the
plus
power
I.
n over I. I together. Right, using that formula, can we try to calculate this question? An amount of 10,000 is to be invested annually at the end of each year for 5 years at 10% compound interest per annum. Determine the present value of this annuity. Let's try that. Are we done? Let's finish up. Let's finish up. Are we done? All right, let's continue. Right? The amount, we are saying 10,000 that we want to calculate how much we are supposed to invest as of today, right? Together for us to get 10,000. So you're saying 10,000 multiplied by 1 minus 1 over 1 plus the interest element 0.1, which is 10% to the power of 5 divided by the interest. So which is 1 minus 1 plus 0.1 is good as saying 1 over 1.1 over 1.1 to the power of 5 divided by that. So you need to calculate first this, right? Together 1 over 1.1 to the power of 5, you get 1.6105. Then you say 1 minus, what is 1 divided by 1.6105? You get 1 minus 0.6209. Then 1 minus 0.6219 divided by 0.1, you get 3.79 multiplied by 10,000, then you get your 37,000, right? Together, you get your 37,000. So that's the amount for present value annuity due. So there is these other also ways of calculating the PV of our annuity. And then we have got present value for perpetuity. Present value for perpetuity, which is PV, is equal to, that is present value for perpetuity is equal to I, that is the investment over interest. Investment over the interest rate or required rate of return, right? Then is that question. For present value perpetuity, PV, this P means perpetuity is equal to I, that is the investment over the interest rate, right? Together. You have invested an amount of money at 8% compound interest and you receive 2,000 annually. What is the present value of the investment you have invested? You're saying the investment amount 2,000 over the interest 0.08, which is 25,000, right? Together, which is 25,000. Then we've got our PV annuity due. Our PV annuity due. PV annuity due. The formula is PV A, that is brackets for PV. Some text you find it's written AD, that is for annuity due, is equal to I multiplied by 1 minus 1 over 1 plus I, n minus 1 plus 1 over I. So you need to calculate items that relate to this. Then you say 1 minus that. Then you say this amount that you get from subtracting 1 from subtracting this element from 1, you divide it by the interest element, and whatever you get, you say plus 1. Are you together? So you first calculate 1 plus I, then n minus 1, you find n minus 1, which is your number of periods minus 1. So we're having this question. So here is showing us the difference between annuity, ordinary annuity and ordinary annuity. So earlier on it was 1 minus 1 over 1 plus I to the power n over I. So that is for ordinary annuity. For annuity due, 1 minus 1 over 1 plus I, n minus 1 plus 1. Same applies to FV annuity. It was what? N minus 1 plus 1. It was more or less the same like this. Right? I want you to calculate our annuity due using this question. You decided to rent out your house for 5 years. You receive 5 payments from the tenants, 100,000 now and 100,000 at the beginning of year 2, 3, 4, and 5. we are required to calculate the PV of the annuity due by using 10% as the discount rate. Or put these figures in that formula.
Phase.
Are we done? Hello, are we done? Right, so in our calculation, it's supposed to be 1 minus 1 over 1 plus our interest element, it's 10. So it's going to be 1.1 to the power n, which is 5. 5 minus 1, 4. So it's going to be 1 minus 1 over 1.1 to the power what? 4. Over 0.1 plus 1, which is like this. 100,000 multiplied by 1 minus 1 over 1 plus 0.1, 5 minus 1 over 0.1 plus 1, which is 5 minus 1, it's 4. Then you calculate what is 1 plus 0.1, which is 1.1 to the power 4. We get 1.4641. We say 1 divided by 1.4641. You get 0.6830. Then 1 minus 0.6830 divided by 0.1, we get 3.1699. You add it to 1, then you get 4.1699 multiplied by 100,000. Are you together? Right? I'm requesting you that you download these tables. We want to calculate future value annuity due, present value annuity due, then present value tables, the future values. We want to calculate all those questions using the what? The tables. I want you to download these these tables, 1, 2, 3, so that we go through it together. Download them, then log in again after 5 minutes.